Hey everybody, Cole here with Classic Mini DIY, and on today's episode we are going to be discussing everything that you can think of about fuel systems. So stay tuned for that. Now, as I said, on today's episode, we are going to be tackling different fuel systems in the Classic Mini, as well as doing a few safety upgrades to my fuel system now that I have a little bit higher flow and higher pressure pump running the fuel system on my car. Now, the intention of this video is to kind of dispel some myths about fueling, about the things that you need, the things that you don't need, differences on some topics, and really to help you guys better understand how the fueling systems work across all the different lines of minis that were out there over the years. Now, because this is a deep dive video, it means that it is going to be a little bit longer than normal. And as such, I am using YouTube's new feature, chapter markers. It's not that new, but you should see along the loading bar, or I guess the progress bar on the bottom of the video, different notches, and that is going to signify different topics in this video. So if you're looking for something very specific about a fuel system, you probably will find it down there in those chapter markers. Now, I encourage you to watch the whole thing because there is going to be a lot of really good information that covers topics that go across all the different fuel systems on a Mini. But my goal is to make this information as easy to access for you as possible. All right, so the first thing I want to dive into, and probably the most contentious thing that we're going to talk about on this episode, ethanol-based fuels. E5, E10, E15, E85, what does all this E mean? Well, let's take a minute and just talk about what ethanol-based fuel is, and then the implications that that has on the classic car community, and more specifically on the Classic Mini. All of these E's that I'm talking about are the quantity of ethanol in your fuel or your petrol. And there are varying degrees of ethanol content in your fuel. And the quantity of that ethanol content is going to have implications on your car. But more specifically, it's going to have implications on your fuel lines and the way that your cylinder head is going to get serviced, as well as the way that things are going to degrade over time. Now, there's this common misconception that ethanol-based fuel is just terrible. Ethanol fuel just damages things, it doesn't give you any benefit, it ruins your fuel, it ruins the way a car drives, and frankly, all of those things are just not true. Ethanol-based fuel is actually extremely knock resistant, and as a result, it has an extremely high performance potential. When you compare it to petrol or just standard non-ethanol fuel, you can do some insanely crazy things with ethanol-based fuel, especially extremely high ethanol contents, if you have a supporting tune on your engine. Now, most of those benefits are only realized in a fuel-injected setup. Carbureted setups, while they could benefit from these things, are much harder to dial in and really get working with a really full ethanol-based setup. Now, that's not to say it's not impossible, but the capabilities of tuning, setting your timing, addressing all of the fuel atomization, all these different things are really much easier to do in a fuel-injected setup. Now, where does that leave Classic Minis though? Because most Classic Minis are carbureted. And as a result, is ethanol bad for a carburetor? Or is ethanol going to cause some problems on your fuel system? Well, sort of. You have to just take into some additional considerations. Now, the one that you are probably most familiar with, if you have run into this issue before or done any research, is the necessity to change out your fuel lines on your Classic Mini. Now, this is arguably the most important thing that you guys could do to your Mini. And in fact, if I bought a Mini right now, brand new, if I bought a used Mini, got it from somebody, the first thing I would do is take all of the fuel lines out of that car and replace them with ethanol safe fuel lines. And there's a reason for this. Traditional rubber that was used on the Mini when it was produced was made to suit a non-ethanol based fuel. And that's an extremely important detail because standard rubbers do not hold up to ethanol based fuel very well at all. The ethanol content, the higher that content, the more aggressive and corrosive that fuel is to standard rubber. And so what you need is a PTFE based fuel line, something that's capable of handling a multi-fuel or a biofuel rated line. This is going to give you the protection you need for an ethanol based fuel. And for just about everybody on the road, granted, there are probably some places that still don't have ethanol based fuel. You probably have ethanol in your fuel, whether it's E5 or E15 or somewhere in between those two. And those numbers are the percentage of ethanol that is inside and mixed with your standard petrol. And so E15 has a 15% quantity of ethanol in it, whereas E5 has 5%. And so regardless of what the quantity of ethanol is in the fuel that's available to you, this is one of the best things you can do on your Mini straight away. Anywhere there is rubber lines, it's worth replacing. Now, the second thing I wanted to talk about with ethanol is the valve seats. The valve seats are cut and made specifically for those valves to seat into and create a perfect seal. And the cylinder heads that were made before were actually made for a couple different things, one of which was fuels that had lead in them. And lead was something that provided an actual lubrication to those valves. And so the metal used on the valve seats was actually a little bit softer than what you have on modern valve seats. Now, with the introduction of unleaded fuel, you then also needed to increase the strength of those valve seats by inserting hardened valve seats. And those hardened valve seats also have the added benefit of being a little bit more resilient to ethanol-based fuels, as they, just like they are more corrosive to rubber, they are more hard on the metals inside your engine. And so it's not something that you need to get dramatically worried about or anything like that. But if you're ever restoring your car and maybe you're rebuilding the cylinder head, it's probably worth adding unleaded valve seats and hardened valve seats specifically so that you can, prolong the life of your engine and it works a little bit better. Now, with ethanol out of the way, let's move on to the next subject. Okay, so now let's step into the world of fuel pumps, because there are a lot of different kinds of pumps, and specifically a lot of different kinds that were sold and installed on the Mini. So what we're looking at here is a kind of chronological order in terms of the oldest style fuel pump and probably the most modern and newest style of fuel pump that's on later Minis and then of course modern cars. So first up, we have a mechanical fuel pump. This pump was available and used for a lot of Minis and actually was installed on the back of your engine block. This little arm right here actually was connected, or at least it sat on your camshaft. And then as your camshaft spun, it actually pumped this, so you can see. And I don't know if you could hear it, but it is pumping air because there's a diaphragm inside here. And as the camshaft spins, it's pumping that fuel at a steady rate and a steady pressure suitable for a carburetor. Now, this is the, as I said, oldest style of fuel pump that you'll see on a classic Mini. And it is my general opinion that this is worth replacing, even if you are, sticking with a carb, sticking with a standard setup. These mechanical pumps have a tendency to fail. The diaphragms inside will, wear over time, and then they tend to leak fuel. Sometimes that fuel can get into your oil. Not ideal. And so I don't really like these that much unless you just really want to keep it original. And so most people will upgrade from this style pump to an electric pump like this standard SU electric pump or this solid state style pump. This one is made by Holley. There are ones made by Facet, SU. There's all sorts of different ones out there. But these are kind of the parallel, both of these are good upgrades from this mechanical pump here. Now, there are a couple neat things and some differences between these. In my opinion, if you are going to upgrade to an electric pump, this is the one that I would pick. They are a little bit more reliable and they are less complicated. They don't have as many parts that can break or wear over time. And in general, when they do fail, they just don't work anymore, which is, it's not the best. You can't service them, but in comparison to something like this is the actual SU branded fuel pump, and this is the electric fuel pump that you can replace your mechanical one with. Now what's neat about this is that technically it is serviceable. You can actually take these apart and they have a points system, very similar to a distributor, that you can then clean, service, and keep these things working a lot longer than you can, definitely a lot longer than the mechanical pump, and in some cases, you know, you might be able to pull a few more years out of this pump before you would have to replace it, as opposed to this pump, which when it dies, it's dead. So this is kind of a period correct style update or upgrade. This one is an acceptable upgrade as well, but it's not technically period. Now both of these are low flow and low volume pumps. They are made for SU carburetors and they aren't intended to be used on a car that needs a really, really high flow and high amount of pressure. Also, with both of these, it is recommended that you use a fuel pressure regulator to properly set the fuel pressure being delivered to the carburetor. Technically, both of these can probably get plumbed directly into the carb, but if you want a really reliable running Mini, I strongly recommend picking up a fuel pressure regulator. Moving on to the next pump. This right here is an externally mounted high flow and high pressure pump. This is something that you might install in a car that has a turbo carburetor or something that you just need more flow and more pumping, more pressure out of. It's a generic unit. This is something I bought from Turbo Fill, but I think these ones are mostly sold in the UK. There's no name brand on this anywhere, so I can't really give you an idea of who makes this. But generally speaking, it's just a generic, nice running pump. Now, the last one that we have here is the later style pump. This is a high flow and high pressure pump. This one right here is a 190 liter per hour pump, and it's made by a company called Walboro. That's a very, very common and reputable brand that makes these small internal pumps. And when I say internal, what I mean is that this pump right here is actually inside your fuel tank. It's fully submerged. Fuel is pumped from the bottom, this little capped thing right here. There's usually a plastic mesh screen that goes on the bottom. Pumps fuel up, out this hole, and then out the top of the fuel tank. This is probably the most common style fuel pump that you'll see in SPIs and MPI Minis, but you'll also see these on most modern cars. Generally, modern cars use a very high flow and high pressure pump, and I'll explain why in a minute. But these are, you know, submerged in the tanks. They're usually relatively quiet. They can be a little loud in the Mini, but overall, very, very good pumps. Now, the pump that you will need will depend solely on the type of setup that you have on your car, whether it's carbureted or fuel injected or something else. Now, we'll jump into those various different types of fuel systems in just a minute, but I want to take a moment to talk about the differences between flow and pressure. All right, so this is a topic that I see commonly misconstrued, commonly misunderstood, and it's really an important topic, something that is worth thinking about, especially when you're doing something out of the normal on your Classic Mini. But there are, generally speaking, two levels of fuel pumps. You have your low pressure and low flow pumps on the left side here, on the right side, I guess, for you guys. And this is what you would see on a standard carbureted car, most likely any sort of older classic British car, but cars that ran Webers, cars that ran other sorts of carburetors, all probably and mostly used a low flow and low pressure pump, unless there was some sort of special setup on that car. Now, later cars and ones that had fuel injection all swapped over to a high pressure, high flow pump so that they could have a high volume of fuel delivered at a high pressure for those injectors. And I'll dive a little bit deeper into that with the diagrams that I show you the different kinds of fuel systems. But let's take a moment to talk about the difference between flow and pressure. Now, flow is a measure of volume of fuel. So what is the quantity of fuel that is being delivered to the destination, or what is the quantity of liquid in general being pumped through this pump. And so this later style pump made for fuel injection is delivering, in this case, 190 liters per hour. So that means it has a volume delivery of 190 liters per hour. You can get these in all sorts of different types. Modern cars can go up to 300 liters per hour, 240, all sorts of different measurements for different cars and their needs. Now the Mini usually gets away with and is fine with a 190 to a 240 liter per hour pump. Those are generally fine, especially for stock SPI or MPI Minis. There are obviously edge cases that require a higher amount of fuel by volume. But by comparison, the lower volume pumps like this one, I actually don't know the measurement for these low volume pumps, but they are usually much lower, around 10 to 15 liters per hour. I mean, dramatically lower volume of fuel being delivered because on a carburetor, it's not necessary. Now compare that to pressure, and this is where they get misconstrued a lot. Just because you are delivering 5 psi or 40 psi doesn't mean you're delivering the same amount of volume, the same quantity of fuel at that pressure. Pressure is how much that fuel really is pressing out, how much pressure is behind the fuel that's being delivered, but that volume can change depending on what kind of pump you have. And so especially with the higher flow and higher volume pumps, you get a measurement and generally a range of pressures that this can operate at. So this pump over here delivers 190 liters per hour at about 40 psi. So what that means is that you are guaranteed at 40 psi to be getting at least 190 or 140, I forget what I said, liters per hour. And so these higher volume pumps like the 240 or a 300 liter per hour will still deliver 40 psi, but it'll deliver a higher quantity of that fuel at that pressure. And so in some setups, you can run into issues with overfueling even if you are at the correct pressure. Now, translating this into a Mini, and specifically a carbureted Mini, if you are using a later style pump, maybe you have a setup like mine, or you have an SPI tank that you have a fuel pump sitting down in, but you have a carburetor. Well, you have this immensely powerful pump that is pumping a large quantity of fuel at a very high pressure. Not only do you have to reduce the pressure on that system, you have to make sure that you are not overflowing as well. So with my turbo carburetor setup, I have to run a return system, but I also have to run a lower volume pump to make sure that I'm not overflowing that float bowl at my lower pressure. And you will probably find that the higher the volume being delivered, the harder it is to get that pressure down to a lower number. So if you have a carbureted Mini, generally speaking, you probably don't want one of these pumps unless you have a really good reason to, like my turbo. But if you have a HS2, HS4, HIF44, it really doesn't matter. All of those are using a float chamber. So you just want to be delivering a standard low flow and low pressure to that carburetor float bowl, either by an electric pump like this with a pressure regulator, or via the mechanical pump that was originally on it. Now, I know that was a lot, and I hope that I was able to kind of separate those two, because they are very important to keep in mind that they are different. But if you have any questions about that, post them in the comment section below, and I'll do my best to kind of outline or update or give you guys some more information if you felt like that was confusing. All right, so let's talk about these three kind of configurations for fueling systems. These are probably some of the more common ones. The first two are probably the most common ones. That's a carbureted Mini and an electronically fuel injected Mini, like an SPI or an MPI Mini. And then the last one is my setup, just to give you guys a little bit of another look at a separate kind of fueling system for a turbo carburetor. But to start off, the most simple, most common setup for a fuel system on a Mini is a single line fuel system, and that is running from a fuel tank in the rear of your car. Normally there is a small low flow, low volume pump that lives underneath your subframe. That's to say, if you have an electric pump, if If you have a mechanical pump, it'll actually live up here in your engine bay and will completely forego the pressure regulator. But with an electronic fuel pump living on your subframe, the weight of the fuel is running down this line and into this gravity-fed fuel pump. This pump usually pumps out at about 3 to 5, maybe a little bit more PSI. Sometimes they get up to 7, depending on the pump you're using. And then you would run that into what's called a deadhead pressure regulator. This means that there is no fuel return on this, and that then meters your fuel down to a fixed pressure. And for most carbureted setups, even Weber's, SU carburetors, all of the ones that you probably see on Minis most commonly, are all within the 3 to 5 PSI range, because the fuel pressure is not what in general is pushing the fuel into the carburetor. What's happening is as air is passing over the venturi, over the open orifice where the fuel comes out, it's actually, depending on the airflow, pulling the fuel into that chamber and then into your engine. So this is probably what most of you have on your car if you don't have an SPI or MPI Mini. Moving on to a fuel-injected engine, this is where things get a little bit more complicated. So you have one of those smaller high flow and high pressure pumps. That pump lives inside the tank. It's actually submerged in your tank. And then that is pumping fuel out to a fuel pressure regulator. That regulator can run pressures much higher than a carbureted car. This pump can also handle much higher flows and higher pressures. And you'll commonly see pressures on fuel-injected engines at 40 plus PSI. It kind of varies depending on the type of fuel injection you have. On Minis, there is no direct injection, meaning the injectors themselves don't live inside the cylinders. They are in the throttle body. And so they live outside in the actual throttle body that's on the outside of your engine. And this regulator is delivering a constant, in this case 40 PSI, at a specific flow to these injectors. So you're getting a constant fuel delivery out of those injectors. All of the excess flow, all of the excess pressure is then rerouted by the regulator. So you're getting this constant flow into the injectors and, in my illustration here, into the fuel rail. And then the excess pressure and flow is then redirected back into the tank, and then it is recirculated. And that fuel just keeps going around and around and around. Now, one of the questions I receive pretty frequently is, can I use a single style setup like this, a single line setup for a carburetor or like a turbo setup or a fuel injected setup? And in general, the answer is no. Because when you run a deadhead setup like this regulator is doing so much work and it is putting so much restriction on this pump here that you end up burning out your pump much, much earlier and very, very prematurely. So in general, this is really for only low pressure and low flow setups. And a return line is something that is basically required for anything that's at a higher flow or higher pressure. Now, moving on to the last one here that is slightly different than the fuel injected setup. And this is what I have on my car. So I have a Mark I Mini. It originally had this setup. Actually, it had one with a mechanical fuel pump. And so my Mini's been since converted, changed all sorts of different stuff to a turbo carburetor setup. And so what I did was I installed an SPI tank with a fuel return. And that's going to allow me to run sort of a similar system to this EFI with one little caveat. So you have this pump submerged, pumping fuel out, really high flow, really high pressure capabilities. This pressure regulator is actually reducing that pressure all the way down to a base of about 3.5 to 4 PSI. And all of that extra fuel and all of that extra pressure is being redirected to the tank. But the reason we need this high flow pump and the reason we need this high pressure pump is because with a turbo setup, your pressure actually gets scaled with the level of boost that is being delivered to the engine. So you have a special air feed that is being directed into the regulator, and this regulator is made to do this. And as you increase the boost, there is a linear progression of the pressure increasing on this regulator and delivering that to the carb. It's a very, very specific setup, and it's not one that you see all the time. But this is something I wanted to mention because lots of cars are driven based on the pressure of the engine and then adjust the pressure as necessary. Specifically, turbo cars is very, very common. So these are your three kind of general setups for fuel systems. There's all sorts of stuff in between these and lots of different opinions and options and all sorts of stuff. But most minis are going to fit into some of these groups here. Now, the last thing that I really want to tackle today on this fuel system video is the ways to make your fuel system as safe as possible, especially if you're using an electric fuel pump. These recommendations do not apply to a mechanical fuel pump because, simply speaking, it's mechanical. There's no electrical stuff associated with it, so these aren't compatible. But if you are on an electric fuel pump setup, whether it is a high pressure, high flow setup or a low pressure, low flow setup, these are absolutely crucial, and I cannot stress enough how important it is to add these if you do not have them in your car already. So let me show you what I've got here. I have two things. One is a high amperage relay. This is something that should be set up on most cars that had an electric pump from the factory. If you added one, or if you have an earlier car, these usually are missing, and I'll explain what this does and what it's important for in a minute. And then an inertia cutoff. Now, this is a safety device that has a little like switch that's based on a certain rating of G-force, but when the G-forces are exceeded on this little device here, the switch inside this rubber cap right here becomes disengaged and disconnects your fuel circuit. So it's going to be a little bit hard for you guys to hear it, I think, but let me show you when I shake this, when I exceed the G-forces on this little device here, you should hear it disconnect. So listen real close. So what just happened is a little mechanical sensor in here has become disengaged and disconnected the circuit inside here. And so the purpose of this is to then stop delivering power to your electric pump, and then in the event of an accident, you wouldn't have fuel continuing to pump, which could introduce a fire, something of that nature. So it's extremely important that these are things that are in modern cars. You don't even think about it, but they are all included and do their job very well on most modern cars. But when you want to reset it, you simply press and click that back in. It's engaged, should hear a little click, and now this is a reconnected circuit. So the idea behind this is that you are adding a certain level of safety to your car. It also will come disengaged if it becomes upside down. This is a very important thing to mention because if you ever rolled your car, which I think is pretty unlikely in a Mini unless you're on the track, this would disconnect that fuel pump, and again, you would then lose fuel pump and lose fuel pumping into your engine and potentially save your life. So lots of really interesting stuff that this switch does. We'll be installing this today. I'm going to show you guys how to do that. But to jump back to this little relay I showed you a minute ago, there's nothing special about this relay. It is simply a high amperage relay. I need a high amperage one because of my fuel pump, but if you have a lower flow, lower pressure pump, you might not need a high amp relay. Now my fuel pump circuit is already on a fuse, which is really good. If you don't have a fuse in line or in your fuse box to your electric fuel pump, definitely want to add one. But what a relay does is it separates the high amperage circuit that is delivering power to your fuel pump in this case from the actual switch that is toggling that. If you have ever heard in your car, maybe your windshield wipers, when they turn on, you sometimes might hear a click behind your dash. It'll go click, windshield wipers run. Click, windshield wipers run. Can be varying degrees of loudness depending on how old your car is. Some of the older ones were really loud. Those are relays clicking. And so what's happening is power is being delivered via a switch or in that case an ECU. In our setup, power will be getting turned on from our ignition switch or our key in the ignition. And when that key ignition turns on, this would make a little clicking noise and connect the circuit, which then would allow the fuel pump to run, allowing that high amperage circuit to pass through the relay and into the fuel pump. But that high amperage circuit never reaches the switch, the actual ignition switch. So it's just an added level of security for whatever fuel setup you have, or really any electrical circuit. These are really good to use on things like rally lights as well, because you don't want the full high amperage circuit line to go inside to whatever little toggle switch you have inside your car, and then out to those lights. It's a really fast way to create a fire and burn out your switch. So you'd have a separate circuit for the switch, toggle the switch, and then the high amperage circuit would roll through this relay and out to those lights. Those are just a few different examples of how to wire that stuff up. As far as wiring this into our fuel pump circuit here, we're going to need to tap into the existing wires, and then we will run some new lines. And luckily, the battery's right back here, so it's going to make running this relay line pretty easy. I'm going to run this. I'm going to pop you guys over here so you can see what I'm doing, but I am going to go ahead and run this, and then I'll show you how it's all wired up, and hopefully that'll help explain it a little bit better. Now, we have our spaghetti wired, and it has been tested and it is working the way we expect it to. Now, I was thinking I would try and show you guys exactly what's happening here, but I think it might be a little bit too confusing with all of the spaghetti kind of just dangling about. So let's take a trip back over to our whiteboard, and I'm going to show you how to do this. All right, so I went ahead and drew this out for you guys to kind of help you understand what's happening. So previously, when you would flip the key, this ignition source right here would simply turn on the pump. So this positive line was connected directly up here to the pump. What we changed was we added two new items into the circuit to add some additional safety. So first thing we added was a relay. Now, the way that the relay works is it has a always connected ground, an always connected hot line, and then the ignition line comes into the relay. This is your switch. I'm calling it ignition, but this could be a switch. This could be anything that would turn on whatever device you want to turn on. And then the accessory line that runs out to what was the positive line on the device. So in this case, it's a pump, could be a light, could be whatever you need it to be. So when you flip the ignition switch, what happens is a little switch inside this relay gets toggled, and this high amperage, fully powered positive line from the battery is now driving the power for the device. So no longer is this switch actually doing the job of powering the device. You are simply using the switch as a signal to then send that high amperage power out. So separates out the circuits, makes it a little bit safer. The second thing that we added is the inertia switch. So this is just simply interrupting the positive line coming from the accessory switch here. If at any point I got into a wreck, flipped the car upside down, this circuit would break that connection and no longer provide that positive line to the pump, therefore no longer providing power to the pump and keeping you from exploding your car. So with all of that connected up, now we have a fully protected fuel circuit, which is really the main goal of this whole setup. Now before this ignition line off this side here, this is actually connected to my fuse box, so it is a fused circuit as well. Something to just keep in mind, you do want to add a fuse even with all of this additional protection. Electricity is funny. It can be really, really bad sometimes, but it can be really great when you have this level of protection in your system. Now, you guys saw that spaghetti that was in the trunk of my Mini. I'm gonna go back there and let's go ahead and tidy that up and get everything looking much nicer so that, you know, when you open up the trunk, it doesn't look like a pigsty in there. All right, so that is looking a lot better. Now, as you can see, I have the inertia switch upright and out of the way here. It's kind of up and above my fuel tank. And the relay is here bolted onto a bolt that I had on the backrest of the rear seat. Now, both of those are up out of the way, but one thing I do want to mention is that the inertia switch itself needs to be upright for it to operate properly. And you're going to want to be able to reach your finger in and actually press the button here in the event that it ever gets tripped. Now, an inertia switch is not an end-all be-all, and in some situations they can trigger themselves inadvertently or unintentionally. If you have one that's doing that a lot, you might want to just go ahead and replace it. It might not be operating as well as it used to. But from time to time, if you hit a really, really hard bump, you could end up popping this inertia switch. So just something to keep in mind as you're driving down the road if you suddenly lose your fuel pump and you don't know why. Now, all of the wires are tucked up really nice and neat. I use something called Tessa tape to keep that, kind of clean looking. And they are all run powers where it needs to be, and we're ready to bring this for a drive. All right, so that is going to wrap up this deep dive into fuel systems on the Classic Mini. I know this was a lot of information, and there was a lot of kind of technical stuff in this, so if you guys have any questions whatsoever, post those in the comment section below, and I will do my best to answer those. So for whatever reason, this subject seems to be very contentious. I'm not really sure why. It's a pretty straightforward process when you get into and actually look at the information, the data, and how everything works. But there's definitely some things that are worth addressing now that minis are starting to live in this world where we have ethanol-based fuels, mixtures, and all sorts of other stuff that's available to us now. I think that there's probably some pretty cool ability to kind of branch into the ethanol-based fuels in the Classic Mini, even just on a standard NA engine. But one of the coolest things about that ethanol fuel is it's very, very knock resistant. And so you can get a lot more timing out of your engines, and you can do a lot more spicy things with ethanol fuel that you can't really do as much in a totally ethanol-free world. But with that, I think I'm gonna wrap things up. I really hope you guys enjoyed this video, and you guys know the drill. Until I see you guys again, enjoy those minis and motor on.